Reinforcement learning grasping with force feedback from modeling of compliant fingers. This work is motivated to grasp grocery objects without bruising them, for example, to pack shopping bags. We aim to train a reinforcement learning grasping controller which uses force feedback alongside compliant gripper fingers. We contribute a 3-degree of freedom gripper design with sensorized compliant fingers and a movable palm, a mathematical model for simulating the compliant fingers, and a reinforcement learning approach which learns grasping in simulation. We achieve a 98% grasp success rate on training style objects and a 95% grasp success rate on unseen and challenging grocery objects. Comparison of simulated and real grasping. We train in simulation using reinforcement learning and our compliant finger bending model to get a best simulation success rate of 91.5%. Then we recreate in real life a version of the simulation test set to evaluate the simulation to real transfer. We achieve a best real-world success rate of 98.0%. Across 3 finger stiffnesses, the average sim to real difference was 3.1%. Evaluating grasps. Objects were placed randomly under the gripper for trials. Success meant picking up the object with limited grasp forces. A stable 5 Newton grasp required tolerating the palm pushing downwards with 5 newtons of force. These objects pass, resisting 5 newtons whilst remaining in grasp. Here, objects fail to resist 5 newtons and don't qualify as stable 5 Newton grasps. Grocery grasping results. We test the generalization of our reinforcement learning grasping controller on unseen and challenging grocery objects. We achieve a 95.8% rate of successful grasps, with 80.1% of these being stable 5 Newton grasps. Our policy grasps highly irregular and deformable objects, such as a bag of salad or a net of tangerines. These objects are far beyond the training set. We also test generalization to the 18 YCB grocery items, which are part of a standardized test set for grasping. Here, we reach 94.4% success rate, and 80.1% of these are stable 5 Newton grasps. Limitations. When fingers can't get under objects, grasps are less stable. But the caging effect can help keep some objects in grasp, even when they slip. Failures occur if objects slip or are pushed out of grasp. But some slips can be recovered using force feedback. Thank you for listening.